Hello, everyone. So this next lesson is on ionic and anionic equations. Now, before you start this, I'm hoping that you've been able to practice a bit and you've watched the video on the solubility rules, because that's definitely going to be needed for this. And you've also practiced balancing equations. But balancing equations, that is something that you've been practicing for a few years now, that you're in the grade 11 chem course. So hopefully that's not too bad. But again, we're going to meet to answer any questions you might have. Okay, so let's move on. Funny looking name here, funny sounding name, not anything that you've quite seen just yet, although it does build on stuff you have done in the past. Can skip over that. Okay, let's practice first. So here we have, just getting my sketch pad ready here. Okay, so we're going to practice a bit. Let's practice writing the ions for this ionic compound. It is aqueous, which means it's going to, when dropped in water, when in water, which it is because we see that it says aqueous here, that will dissociate or ionize to create two different ions, in this case sodium and carbonate, right? So we'll also need to remember that this is a polyatomic, that it has a certain charge. Again, a tip, do the reverse crisscross rule, right? So the charge on carbonate or CO3 is -2. That 2 is right here, it helps you with that. Okay, so we have sodium and carbonate. Now, your answer is we have 2 sodium ions, right? It does have to be balanced. So that 2 subscript means that there are 2 sodium ions. So when we dissociate this, we get 2 sodium ions and 1 carbonate ion. Don't forget, since they're ions, let's switch to a pen here. Since they're ions, I don't think I did that. Okay, since they're ions, we do need to make sure that the charge is present, right? You have the correct coefficient that matches the number of sodium ions there are, and that you include aqueous. Okay, so moving on. Okay, let's practice again. Let's write ions now. For these two, we have calcium phosphate and cadmium nitrate, both aqueous. Let's write their ions. Here we have, I'm going to ask questions. It's going to seem kind of funny since I have no one around me right now to answer these questions, but think about what the answer is. So how many calcium ions are there and how many phosphate ions are there? Go ahead, say the answer in your head or out loud. Right, if you said 3, right, there's a 3 subscript for calcium, then you're correct, and you have to remember that the charge on calcium is +2. Right? Phosphate is a polyatomic, and that has a charge of, if you forgot, here it is right there. Reverse crisscross it, it'll be -3. Don't forget to write aqueous for both. Right, and there are 2 phosphates because of that subscript here. Okay, cadmium nitrate, there is 1 cadmium, right, just 1 cadmium. It will have a charge. There's a charge right there, reverse crisscross that, and write aqueous. So +2 aqueous. Nitrate is a polyatomic, and that has a -1 charge. If you forgot what that charge was, look over here. There's an imaginary 1 there. It has a -1 charge, and there are 2 of them. So you write 2 nitrates, right? Each one with a -1 charge. Okay, let's move on. Okay, we're taking it slow. Here's another question. Here's a typical question you would see. This is a molecular equation, cadmium nitrate, sodium sulfide, both aqueous. In this case, we see that according to our solubility rule, this will produce, this double displacement reaction will produce 2 products, cadmium sulfate, sorry, I said sulfate, common mistake, cadmium sulfide, and sodium nitrate. Looking at your solubility rules, if you refer back to them, you'll be able to figure that out yourself. This is a typical question you might get. Often what you'll see is, and however I'm going to be able to test you, is that I will not give you the products, right? You'll need to figure out what those products are. Then also figure out if there is a precipitate formed by one, in other words, if it is a solid, and if one has, or if they're both aqueous, if they're both soluble in water, in which case there will be no products. Okay, so we can write this as an ionic equation. So here are our reactants. Oops, don't know how that happened. Let's undo that. Okay, select tool. Where'd my marker, my pen go? There we go. Okay, so here right? Here are our ions. So cadmium has two of them, right? There are two cadmiums, right? It has a +2 charge. Nitrate, there are two nitrates, each one with a -1 charge. Sodium, there are two sodiums, each with a +1. There is one sulfur or sulfide, because it's an ion, with a -2 charge. All written out here. Okay, now our products, let's write that out in ionic form. Except note here, this part is different. Cadmium sulfide is a solid. In an aqueous solution, or in water, that will not ionize. It will not break apart into its ions like the rest have. Let's change that tool. So instead, what we get is this. Whenever you see solid, what that just means is you're going to rewrite it exactly as it's seen. Whenever you see aqueous, that's when you break it up into its ions. So sodium nitrate in this case, sodium nitrate is going to break apart into its ions, two sodiums and two nitrates, right? I want to make sure to take a look at this here, or focus on this a bit. There are two sodium nitrates. The coefficient is on the outside of sodium nitrate, on the outside of this compound, of this substance. So that means that the 2 applies to both sodium and to nitrate. So there are two sodiums and there are two nitrates. Don't forget their charges, positive for sodium, +1 for sodium, and -1 for nitrate. Okay, that is essentially your total ionic equation, right? All of the ions, or all of the substances that are soluble inside an aqueous solution, are broken apart into their ions and written as such. Okay, normally in class we would have practiced that together. Whenever you see this timer here, if I forget, take a moment, pause the video, and try doing it yourself, because you can do it. And remember, if you make a mistake, it's okay. There's no negative repercussion for giving it a try. Okay, about to move on to the next slide. Here we go. Okay, so continuing. So in the last slide, you completed a total ionic equation. The next step to that, though, is to figure out what the net ionic equation is, right? The net ionic equation. So what that involves is figuring out what appears on both sides, in your reactants and in your products. Whatever appears on both sides wasn't actually involved in the reaction. Sure, they're there, we can't forget that they are there, but they're not actually involved in the reaction. So what we can do is we can just X them out, get rid of them. So what appears on both sides? Take a second before I place this X to look at this equation again, both reactants and product side. We can see that nitrate appears here and here. So that cancels out, right? Then sodium appears here and here as well. So that cancels out. What we're left with is this cadmium ion, this sulfide ion, creating cadmium sulfide. So the only true reaction happening here is this. And this is called your net ionic equation. Essentially, that's it. So if that made sense to you, great. We're just going to practice a bit more. Okay, but let's continue practicing. Okay, reminding you though, I have to remind you that on both, so materials have to be balanced on both sides. That means before you start this, so here in this question, this is a fully balanced equation. Fully balanced, correctly balanced. If it weren't, it wouldn't have worked, or it likely wouldn't have worked. Right, so make sure that both sides of the equation, or rather the entire equation, is balanced. And that at the end, when you do come up with a net ionic equation, check to make sure that you get an equal number of atoms on both sides. Okay, so ions that aren't involved in the reaction, this isn't anything new, what I have on this half of the slide. It's just a screenshot of this. So whatever you've crossed out, those are called spectator ions. So let's circle those. Let's see, we have nitrate here that appeared on both sides. We also have sodium that appeared on both sides. Those are called your spectator ions. So you will be asked at some point, let me see if I can have a spot to write that down here. I don't. Right, so you will be asked in these questions, in these sorts of questions, to list or state what are your spectator ions. And in this case, we have two. We have sodium, sorry, I'm saying sodium, I wrote nitrate, NO3 aqueous, don't forget the charge, that is a spectator ion, and we have sodium ion as a spectator, as your spectator ions in this case, right? So these are your spectator ions. Think of them as if you were watching a game, a sports game, a hockey game, baseball game, whatever it may be, and you're the spectator, and as much fun as it can be, and you may think you have some effect on the outcome, you really don't. You are a spectator. You can enjoy the reaction, you can enjoy the game, but these are not involved in the reaction at all. Okay, so our question. When sodium hydroxide and magnesium chloride are mixed, blank solid and sodium chloride are produced. Write balanced molecular, ionic, and net ionic equations. Okay, you can do this. Looking back at what we've done, here's a timer. In class, we would have practiced this all together, so if you'd like to pause the video right now, give it a shot, would be a great idea. You can pause now. Right. Hopefully you did, and you really did give it a try, and it's okay to stumble. It's okay to take a second and figure out what is happening here, what do I do next? It's better to do that than to just watch me, hear me go over this. It helps to try. Okay, so first step, write your skeleton equation. Before I show you, skeleton equation just means your reactants, it's mentioned to you or it's stated in the question, right? That's a reactant, that's a reactant. Write that down. What you're missing though is you're missing a product, and you do have another product here. So that can be figured out if you reviewed your, so this part of the question can be figured out if you reviewed your types of reactions. This is a double displacement reaction. Now we know that because we can hopefully by now identify that A, B reacts with C, D. This begins to look like the general form of a double displacement reaction. So if sodium and chloride become sodium chloride, that means magnesium and hydroxide must become magnesium hydroxide. Right? So that is our missing, maybe I'll fill that in right now. That is our missing link here. We have magnesium hydroxide. Okay, now magnesium hydroxide, it has to be balanced. Right? Magnesium has a positive 2 charge. Because hydroxide has a -1 charge, that means we need 2. Oops, write that down a bit better, hopefully. Okay, we have 2 there for hydroxide to balance out the positive 2 charge for magnesium. Your skeleton equation is essentially this all written out with an arrow between them. Now I have coefficients already included here, so you can see I already wrote this part out, magnesium hydroxide. Your coefficients here, that would make it a balanced molecular equation. So go through it, balance, you've had practice with that, practice in previous years, practice in class. You has to be balanced. Okay, so that is your first step, right? I've included the answers here, but you would want to balance that next. Okay, so that's your balanced molecular equation. Then break it up into your ionic equation or your total ionic equation. We practiced that as well. Look, here we have sodium and hydroxide. Break those apart, they're aqueous. Magnesium and chloride. Break those apart. Magnesium has a +2 charge, chloride has a -1 charge, but there are 2 of them. So 2 sodiums, 2 hydroxides, 1 magnesium, 2 chlorides. Then back here, magnesium hydroxide, following your solubility rules, but also just in the question itself. So you actually didn't have to look at your solubility rules, but if it wasn't given to you, then you probably would need to. You would need to. We figured out that this is solid, so we don't break this up at all. This does not ionize. Sodium chloride does. Look, it's aqueous. We have 1 sodium and 1 chloride. This is our total ionic equation. Now, what do you see on both sides? right? Well, what ions do we see on both sides that we can begin to eliminate? Here we see sodium on the right and sodium on the left. Those are going to cancel. What else do we see? Hydroxide. No, we don't see hydroxide on both sides. Magnesium. No, we don't see them. You might be thinking, yeah, but it's right here. Okay, they have to be exactly the same. They have to be Mg2 plus Aq on the left, Mg2 plus Aq on the right in your products. We don't see that happening. We skip over that. What else do we see? Two chlorides. Two chlorides. Perfect. Has to be exactly the same. Right? That's it. That's all we can cross out. What we end up with is our net ionic equation, and that looks like this. Let's double check to make sure we're okay. We have two hydroxides, two hydroxides. That part's balanced. One magnesium, one magnesium. Good. So this is the net ionic equation. This is the reaction, the only reaction that's happening. The other ions here, they are your spectator ions. Although the question wasn't asking you to figure that out or to list them, you could be asked that. Here's some extra practice we would have done in class, but you can certainly practice this. Ask what the solutions are. We can go over it at when we meet online. That's it for net ionic equations and total ionic equations. Your lesson is posted online. This is all posted online. So is the worksheet. Tune in next time.